slope, right? And so even though it tells you exactly what to do, even if you get caught up. So on every test, you always get that formula sheet. So what we're going to do is we're first going to find it from a table. And so do you guys see how it says find the rate of change over an interval? Do you guys see that right here? Find the rate of change over an interval. That means because it's exponential, it's not going to be the same. Remember how we subtracted 3 each time? Exponential is not like that because it's multiplying. So they want you to take, this means your x values right here. So right here, when I'm looking at my x values, they want to find when your x value is 1 and when your x value is 4. So it looks like that. So it looks like that, and we're not even on our notes. And so when it says the interval, they're talking about your x value. So find the point where x is 1 and find the point where x is 4. So I don't want you to get confused because it's not saying 1, 4. It's telling you to find the rate of change over that interval. So all you do is write them as points, 1, 1, which is right here, and 4, 6. Does everyone get that first part? First, I wrote them as points. Then I'm finding the rate of change, which is the same thing as what? Slope. And so the slope formula is right above. We know it's y2 minus y1 over x2 minus x1. And so this is the last lesson of this unit. So make sure that we're paying attention because after this we review and a test. Then I label. So x1, y1, x2, y2. Then I just plug it into my equation. So 6 instead of y2 minus 1 instead of y1, and then 4 minus 1. And you can just type that right into ND on your calculator if you want, or else you could solve it by hand. What is 6 minus 1? 5, and what's 4 minus 1? 3. And does that reduce that fraction? Nope, so that's my answer. Yep, so we're just finding the rate of change, but they're asking, the main difference is now they're asking over intervals. So let's try this one right here. It says find the rate of change between that interval. So these numbers are your x values. So I look and I go, okay, where is there 2 in the x value? Right here, so I'm using this point. Where is there 3 in the x value? Okay, I'm using that point. So those are signifying the 2 points they want you to use. And so I know it's 2, 5 over 2, and 3, 5 over 4. Then you could just put it into your calculator. So when I put it in, I label my points. So I have x1, y1, x2, y2, and plug it into the slope formula. So I have 5 over 4 minus 5 over 2 over 3 minus 2. So this is nothing new, it's just average rate of change. When I do that, I end up getting negative 5 over 4 over 1, which ends up just getting you negative 5 over 4. Does this make sense? I'll do one more with you. So if you just came in, make sure you're like sitting down paying attention because we're already halfway through the lesson. So this says find the rate of change over this interval. We remember rate of change means what? Slope. You're finding the slope. So the first thing you do is these are your x values. So circle the 2 points that you're going to be dealing with. So when is your x negative 2 and when is your x 2? So you would look over here and go, okay, here's my first point because that's negative 2. And the last one? Yep, and then it's the last point because I wanted at 2. Then we just find the slope. So first thing we do is label, x1, y1, x2, y2. Then we just plug it into our slope formula, which is right here. And you're always given it. So right up here real quick, I'll scroll back down. But right here is your slope formula. It's always on your formula sheet. You just need to know when to use it. So I have y2, which is 243. 2 minus negative 2. Be careful. A lot of people are getting this wrong because they're doing 2 minus 2. But it ends up being 2 minus negative 2, which ends up being a plus, right? And so you should get 240 divided by 4, which ends up being what? You're right. What was it? 60. That's your slope. So see if you could try the last one on your own, D. So it says find the interval between 4 and 6. So see if you could set it up the exact same way you set it up on here and find the rate of change. I'll give you mine. Yeah, I'll print it out. Next one's equations, the second half of that sheet. Is everyone on it? So see how it looks the same? So they're saying find my y values when x is 0 and when x is 2. So it looks like that. Do you see that up there? So they're saying find it when x is 0 and x is 2. So what are you going to do? You're going to go to table, or you could just type the equation in. So go to table and do 2 to the x and find what is your y value when x is 0 and what's your y value when x is 2. So you're typing that equation into from right here, because they're saying find the interval between 0 and 2. So look on your table. So when you look at when 2 is 0, x is 1, or sorry, y is 1, and 2 is 4, correct? Did everyone get that? Is anyone confused how we get these points? Yeah. So all you do, they're saying find, you get why we use 0 and 2, because they're saying find the rate of change when the interval is 0 to 2. Then all you have to do is put it in your table, and you're looking at the table, and so when x is 0, it was 1 right here, and when x was 2, it was 4 on your table. Like you're just typing it into table. 2 to the x. Yeah. And then all you do is find the slope. So I label, and plug it in. And so it's 4 minus 1 over 2 minus 0, which ends up getting you 3 over 2, which is reduced. Let's try this one right here. And so if you don't feel like putting it into table, you can just plug each of those x's into your x. And so right here, they want to know when x is 1, what's my y? And when x is 3, what's my y? The easiest way is to just go to table and type that equation in. So go to click on table and type in 3 to the x plus 1. So you're going to table, I'm just typing it in. And then we're saying when x is 1, give me the y. When x is 3, give me the y. So just writing down the points. 4. So when x is 1, what was the y? 4. On your table? 4. And what about 3? 28. You multiply. Don't multiply. Or you put 3x in your calculator. Right? Because 3 times 3 is 9 plus 1 is 10. Be careful. Cool. Now I just labeled just like I did. x1, y1, x2, y2. And then you just plug it into the slope formula. And so it's y2, 28, minus y1, which is 4, over 3 minus 1. What's 28 minus 4? 24 divided by 3 minus 1. That's 12. That's your slope. See if you could try the next one on your own. So you know, first set up the points, put it in your table, and then find the slope. So see if you could try the next one. And so this is what you did with Miss Thompson the other day. Remember when we looked at a graph and we found like f of something? Yes. So we're doing the same thing here. So right here I look and I see, okay, I'm finding when x is -1 and when x is 2. Same thing we've been doing, right? So we're on that first graph on your page. All I did was write the points, like that. Then I look and I go, okay, is X side to side or up and down?
Side to side.
Side to side. So I'm looking when X is -1, and I'm going to keep going until I find it falls on this point right there. Do you see that? So I go to -1 and I drag my finger up till it touches that line. Where does it touch that line? What's that Y coordinate? 8. 8. So at -1, it's 8. So make sure you're on the right page and writing this down.
I was looking at all of them.
Yep, and then I go to 2 and I drag my finger up and it hits at 1. So it'd be 2, 1.
This is easy.
Yes. Yes. And so know that it's going to be a negative slope because see how it's going down?
Yeah.
So you know your answer should be negative. So now you're doing the exact same thing. X1, Y1, X2, Y2, and we plug it in. When you do that, we do 1 minus 8 over 2 minus -1. What do 2 minus signs make? A positive, a plus. So when we do this, you end up getting
-7 over 3.
So you can put this in ND if you want, that's fine. But if you're doing it by hand, just remember, a lot of people drop that negative. So when I do that, I do -7 over 3, and that can't reduce anymore, so that's my answer. Does that make sense? It's just the same thing 3 different ways. We'll do one more. So, but I need everybody quiet. So, when I'm looking, these are my 2 X values, 0 and 1. So first thing, we're on the second graph, 0 and 1. Then I look and I go where X is 0 and I drag my finger up until it hits this line. What did Y value is that?
3.
Beautiful, 3. Then I go to 1 and I drag my finger up until it hits at 6. I know it's going to be a positive slope because it's going up. And so now I just write in the equation, x1, y1, x2, y2. And so you end up getting 6 minus 3 over 1 minus 0. Which will end up getting you 3 over 1, or 3 if you put it into your calculator.
Here.
Cool. Does that make sense, how we found those points? Okay, see if you could try the 2 underneath. So when we plug this in, I end up getting 19,178 minus 32,477 over 10 minus 5. In one. Which makes sense, right? So that means, and we want to interpret what it means. It means on average, between 5 and 10 years, on average, between 5 and 10 years after purchasing a new car, the car decreases in value by, per year. And so remember, this is just between, we're just doing the new car for right now. But so between 5 and 10 years, that car falls in value, it decreases, it's negative $2,660 per year. And that's also why a lot of people lease cars, because if you're one of those people that changes their mind or needs a new iPhone or needs the new this or new that, a lot of people lease cars, but you never actually own it. So you're actually just paying to rent a car, but it's never gonna be yours.
Wait, so you're gonna pay money to rent?
Like if you lease, you ever hear of leasing a car or the commercials on leasing?
Yeah.
You're paying money every month, but you're never getting the car. Like, but if you were to buy a car, you pay each month, but the car will eventually be yours. You're paying it off. But if you lease a car, you're just paying basically to rent a car, and you have to give it back at the end. You never get money out of it. And so that's the difference. Okay, next one says they want to find the new car, they want to know how much the price is decreasing from 10 to 20 years. So go back to your table and find what the value is. We already got 10. What was 10? What was 10 at 10 years? You already got it. 10, 19,178. Now look up how much is that car worth 20 years later. And think about it. You guys aren't even 20 years old. So to have a car for 20 years, not many people.
It's pretty rare, so. You know.
I'm 20 and spending.
That vintage, like vintage type cars, they will increase the price. But these ones, no. So did anyone find how much is that same car on your table worth in 20 years? You don't even need to.
In my fair period.
Does anyone get it? 20 years? What is it? You're on vintage car. The same equation. You were just all right, so 6,687. So listen, this is the last part. See how I wrote these as points?
Yeah.
And so at 20 years, that $55,000 car is worth $6,000. But now let's find the rate of change. So label, plug it into your slope formula.
Oh, it's good, that's 20.
Yeah. 20 years is a lot. So now label, plug it into your slope formula and see what you get. See if you get the same slope. Make out 5 minutes. So you're plugging this into your slope formula. So 6687 minus 19178. Amaya, what did you end up getting?
Negative 1,249.
That's not bad. So notice. What? Do you see how our slope is a smaller number? So what happens when the car's new, between those first 10 years, it drops in value a lot, right?
Yes.
But by 10 to 20 years, when you look at an old car, it's old, right? Like if you look at a really old car, there's not like, oh, 2000 whatever, it's old. So when it gets like 10 to 20 years old, it doesn't decrease in value as much. So see how this is only $1,000 and that's $2,000 per year? That's why that curve is like this. And so the sooner you bought the car, the less value. So even driving it out the dealership and coming back, that probably drops it $10,000.
What?
You probably lost $10,000 just from driving it out a lot. So some people buy used cars, but they're actually not used. Someone drove them out a lot, threw them back, and that's considered a used car.
Oh, that's true.
And so you get it for cheaper.
It's used though.